Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the TEAS. We have been solving math problems out of this book here, the study manuals for the TEAS. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 62. Please turn to it. Page number 62, and today is our lesson number 12. We have two problems left here, problem number 2 and 3 from yesterday that we have to finish. Let's take a look at number 2 first, obviously. Number 2 says, what is an approximate decimal equivalent of cube root of 10. First thing first, let's make sure we understand how to read this thing. This thing is read as cube root of 10. That's how we read it, cube root of 10. And our job is to find the approximate value of this quantity, cube root of 10. Now we already know, so here's our solution. We know that cube root of 8 of course can be written as 2 times 2 times 2, and cube root of that quantity. Cube root simply means what number multiplied by itself and then multiplied by itself one more time will yield the number that we see under the root sign. For example, here when they ask us what is the square root of 49, what they're asking us is what is that number which, there the question is, what is that number which when multiplied by itself yields 49, gives us 49. The answer of course is 7, except under the cube, in the cube root we're not multiplying by itself just one time, but 2 times. We multiply it and then we get the result and we multiply one more time. So as you can see, 8 is same as 2 times 2 times 2, and now we have our answer. What is that number? That number is 2, because 2 multiplied by itself and then the result being multiplied by 2 again will yield 8, and therefore the cube root of 8 is 2. Similarly, we know that the cube root of 27 should be, 27 can be written as 3 times 3 times 3. So what is that number which when multiplied by itself 3 times 3 times 3 times 3 and 3 times in a row yields 27, and the answer is that number is 3. That number is 3. What we have here is 10. 10 lies somewhere between 8 and 27. And our job is to figure out where does it lie from between 8 and 27. Where does it lie? As you can clearly see, it lies someplace very close to 8. So if you were to put it on a scale here, the two ends being 8 and 27, the cube root of 8 here, which is 2, and the cube root of 27, which is 3, 10 here, which is what we want to find out here. Cube root of 10 is what we are interested in. Cube root of 10 here. Which is what we are interested in, should lie someplace very close to 8. Are you with me so far in the story? That tells us we do not know what the cube root is. We do not know what number multiplied by itself and then result being multiplied by one more time by that same number will yield 10. We do not know that number yet, but whatever the hell it is, we can conjecture, we can surmise that it is very close to 2. Let's try 2.1, shall we? Let's try 2.1, shall we? Let's try. Let's see what happens. We need the room obviously, so we have to erase it. Just give me 1 second here. We're going to multiply 2.1 by multiply 2.1 itself 3 times. Just for the hell of it, to see what it gives us. Let's try 2.1. Times 2.1. Now, as we know from the last few days, when we have to multiply a decimal number by another decimal number, we don't have to worry about the decimal point right from the very beginning. We can just multiply 21 by 21 by itself and see what it gives us, and we'll worry about the decimal at the end. So let's multiply 21 by 21. 21 times 21, 1 times 21 is just 21, and then 2 times 21 is going to be 42. So we get 1, 4. Now this represents, 441 represents square of 21. We don't want square of 21, we want a cube of it. So let's multiply it by 21 one more time. And we will get 441 one more time here. And then times 2, so we get 2, 8, and 8. That gives us... The idea is to keep your work neat, keep your work clean so that you can follow it. If you keep it messy, messy work on a scratch paper is an indication of messy thinking. As I always tell all my clients, your work must be clean. The cleanliness on the piece of paper. I know I'm breaking into sermon and you hate sermons because I'm not teaching SAT student here. I'm not teaching 16, 17 all right now. I understand that you're a grown person, but the sermon, here it is nonetheless. Messy work indicates messy thinking. Keep your thinking clear. The way you keep your thinking clear is by keeping your work clear on a piece of paper. It has to look good. It has to look clean, as you can see clearly here. And now we're just going to go and insert our decimal. It's not 21, it is 2.1. It is a 2.1, so we put it here. So we have one decimal place here, we have one decimal place here. So we have to move it 2 decimal places to left, this answer here. So this becomes 4.41. And then we have 2.1 again. So now we have 2 decimal places, 1 and 2. And here we have another one place. So this final answer has to be, the decimal place has to be moved 3 places. So decimal places here, we have to move 3 places, 1, 2, and 3. It ends up here. Well, that gives us 9.2, 9.26. We need 10. I don't know about you, but I don't like it. 9.2, in my opinion, 9.26 is too far away from 10. That's too far away. Let's try 2.2. Let's try 2.2. Now, had I been doing it by myself, I wouldn't have bothered with 2.1 to begin with. We would have realized, we would have had a gut feeling that 2.1 is going to be too small. Even though 10 is very close to 8, still 2.1 is just too close to 2. Let's try 2.2. 22 times 22 is just 4 and 4, 4 and 4. So you get 4, 8, 4. Again, 484 represents 22 times 22. We got to multiply this result by 22 one more time. So let's do it. Times 22. And we'll find 2 times 4 is 8, 16, and then carry 1, and then 8 and 9. And we're going to have the same number one more time because it's again 2. So we can have 8, 6, 9. 8, 6, 9. 8, 6 and 8 is 14, carry 1, that becomes 10, plus 6 is 16, carry 1 and we get 10. And now we insert our decimal, 2.2 and 2.2, that gives us one decimal place, another decimal place. So here we have to move our decimal place 2 places, 1 and 2, 4.84 times 2.2. Now we have to move our answer 3 decimal places. It's here, 1, 2, 3. 3 decimal places. Now we got just the opposite problem. Keep listening. Now we got just the opposite problem. Now it's too high. We need 10. 10.6, 9.2. Before we are 0.8 short, now we are 0.6 over. So somewhere in the middle, this is 0.8. You see we are off by 0.8. Here we are over by 0.6. It's somewhere in the middle. Because it is somewhere in the middle, it is quite alright, it is quite appropriate. Even if you leave it here, if you tell somebody that the cube root of 10 is approximately 2.2, or if you tell someone that cube root of 10 is approximately 2.1, I assure you, nobody's going to knock on their door at 2 in the morning to arrest you. It's okay. But if you want to do a little bit of a better job, would be to say that cube root of 10, now that we know that this is way too under and this is way too over, it's somewhere right in the middle. It's not 2.1, it's not 2.2, it's approximately 2.15. Voila. Now I'm fully cognizant of the fact that you do not have this kind of luxury in the exam to analyze it to depth like I just did. This is purely for learning purposes so that you get the feeling for the numbers. You have to have gut feelings, you have to have intuition behind it. You understand? That's what it is. They're just trying to see if you can quickly estimate what it might be. Well, right off the bat we know it's a little over 2. That part is very simple because cube root of 8 is 2, cube root of 27 is 3, 27 is way over there, 10 is very close to 8. So we know it's 2 point something. It's either 2.1 or 2.2. So I would have tried 2.2 first because 2.1 seems too small to me. When you try 2.2, you could stop right there. And if you say that cube root of, as I said before, if you were to claim that cube root of 10 is approximately 2.2, it's okay. It's perfectly fine. There is nothing wrong with it. This is just a little bit more. This is just a little bit more refined, a little bit more elegant. That's all. Let's do the next one, shall we? Yes, I know you're shocked to be hearing these kind of adjectives to be applied in a math problem. Elegant and refined, that is. But that is what makes us geeks. That's right. You have to put an effort in it to get there. Should I erase it now? We're all done, shall we? Move on? Let's do that. Just give me a second. There is beauty in math. Don't get me going there, don't touch my nerve, because otherwise I'll go on forever rambling, because I do not know why kids get turned off. Well, they do not get turned off. Kids are turned off in the school. I don't know who the hell does it. Teachers, whoever, I don't care who you blame. But they get turned off. They don't like math, which is a horrible thing. How can you not like math? The entire foundation of modern civilization is based on math. Everything that you see around is based on math. We cannot build anything without math. Anyway. Amen. I'm done with the sermon. And they get turned off from the very early age, which is a shame, which is a damn shame. Number 3. What irrational number? What irrational number can be approximated by the number 3.3166. Oh boy, that is a tricky one. That is a tricky one. Let's see what we can do. Now, as soon as we see the word irrational number, listen very carefully as we talked about it. As I always remind you, you must watch the video in sequence. It is vital, it is important, it is imperative that you watch them in sequence. Otherwise, we'll never get anywhere because everything builds on everything. Not yesterday, but day before yesterday, the entire video was on the concept of rational and irrational numbers. And there, and also yesterday somewhat, we learned that most square roots are irrational numbers. Most of them, not all of them. Obviously, square root of 25 is not irrational because that's just 5. But square root of 26 will go on forever. That's an irrational number. Square root of 37, as we learned yesterday in one of the problems, is irrational. Most square roots, if you punch in 37 and take a square root of it, you will see that it goes on forever. It's an irrational number. Now going on forever by itself does not make it irrational. What I should clarify it. I should qualify my statement by saying that not only the answer will go on forever, not only it will be a non-terminating decimal, but it will have no pattern. You understand? You must qualify your statement by saying that part. What does it mean to qualify? What does it mean to qualify one's statement? Are you interested in learning that word? In case you, I don't know, maybe you do. Obviously, it's your native language. I shouldn't take liberties. But anyway, for whatever it's worth, day number 27. Just type in vocabulary. Always type in my name first. If you're going to search something in YouTube, just type in Keshwani and then put in vocabulary words, day 27, or simply vocabulary, day 27. And in that video, we learn what it means to qualify in statement, which is what we just did here. Simply saying that square root of 37 is going to go on forever, simply saying that the square root of 37 is going to be non-terminating decimal is not enough. We must qualify that statement by saying that also it has no pattern. If it had pattern, then even if it is non-terminating, that does not make it irrational. That would be 0.33333 is quite rational. It's 1/3. What I'm trying to make you understand here is that because most square roots are irrational, listen carefully, it's just a gut feeling, okay? Since most square roots are irrational, and because the math in this exam does not get too complicated, my gut feeling tells me that this answer that they're presenting here must be a square root of something. Let's try that, shall we? Let's try that. And how do we find out if it's square root of something or not? Well, let's find out. Let's see what we get when we square it. When we square it, let's see what we get, because when we square it, then that number, square root of that number will be this 3.3166. That's what it is. Okay? Maybe it's a square root of something, as I said, it's just a gut feeling. So let's do that. Where can we square it? I need the room. We need to multiply it. Let's do it here. 3.3166, 3.3166, and we have to multiply. We're going to square it. Now listen very carefully. As I have reminded you several times in the past, today is our 12th meeting, and if you've been watching this video by now, you know that I remind you that this is a multiple choice question. This is just TEAS. Calm down, relax, take a deep breath, take the exam. We're not sending a rocket in the sky. Do you understand? We're not performing an open heart surgery. This is just a freaking exam. Just chill and I can't believe I said that, and take the exam. I don't know where I picked it up from. Perhaps from a 10-year-old. Who knows? The key here is to stay calm. Stay calm, stay collected. You must not be perturbed by anything that is presented to you. Do you understand? You must not be shaken by it. And you must learn to approximate. As I said, we're not performing an open heart surgery. We do not need precision. I'm not going to waste time here trying to multiply this freaking thing 3.3166 by 3.3166. Just try to multiply these two numbers by hand. Will take forever and ever. Let's approximate, shall we? I'm going to pretend it's I'm going to pretend that it is 3.32. Shall we? It makes it easier for us. It cuts down the work quite a lot. Even this is too much work if you ask me, but we have no choice. Let's do it up here so that we have a little room to go someplace. And again, I'm not going to worry about the decimal. So it's 332 times 332. And we'll worry about the decimal at the end. Let's get going, the top. So times 2 is just 466. Times 3 is going to be 699. And times 3 one more time is going to be 699. That was quite straightforward. That one quite smoothly, even though I say so myself. 6 plus 6 is 12. Carry 1. 1 plus 9 is 10. And then 6 plus 6 is 12. 12 plus 10 is 22. 2. Carry 2. And 9 plus 9 is 18, plus 2 is 20, 0, carry 2, and 2 plus 9 is going to be 11. Oh, what do you know? By golly, what do you know? That tells us that the square root of 11.0224 is exactly equal to 3.32. Oh, I shouldn't have put the decimal here right now. We have to explain it. And now we go and insert our decimal. So this was 3.32, we have 2 decimal places. This was 3.32, we have 2 decimal places. So our final answer, whatever it is, we have to move the decimal 4 places. So let's do that. Decimal is right here right now, as it exists. We have to move it 4 places. 1, 2, 3, 4, right here. Voila. So that tells us the square root of 11.0224 is exactly 3.32. Therefore, I would say that this is probably, most likely, this number represents the square root of 11, because this is 11.02, you see? That's what it is. So, what irrational numbers can be approximated by the number 3.3.316? The answer is 11. Answer is square root of 11. That's your answer. Square root of 11 can be, in other words, what we are saying is that the square root of 11 can be approximated as 3.3166. And I would bet you that if you pick up a calculator and actually did figure out the square root of 11, the first 4 digits after the decimal, you're going to find it's going to be the first four decimal, first four digits after the decimal, you're going to find that are going to be 3166, and then of course it will go on forever. So it's going to be non-terminating, non-repeating. It will have no pattern, because if it did have a pattern, it wouldn't be irrational. I'll see you tomorrow, okay? Bye now.